How do microstates relate to entropy? Imagine a room filled with tiny particles moving around. Each particle's position and energy can be arranged in countless ways. These arrangements are called microstates. Now, think about how many different microstates a system can have. The more microstates, the more ways the particles can be arranged without changing the overall appearance of the system. This is where entropy comes into play. Entropy measures how disordered or random a system is. If there are many microstates, the system is more disordered and the entropy is higher. If there are fewer microstates, the system is more ordered and the entropy is lower. The relationship between microstates and entropy is explained by a famous equation called Boltzmann's equation. It states that entropy equals a constant times the natural logarithm of the number of microstates. This constant is called the Boltzmann constant. So, if the number of microstates doubles, the entropy increases by a specific amount. This means that a system with more microstates is more likely to be in a state of higher entropy. Think about a gas inside a container. When the gas is confined to one side, there are fewer microstates because the particles are limited in where they can go. But if you open the container and let the gas expand, the particles can spread out in many more ways. The number of microstates increases dramatically, and so does the entropy. That's why gases tend to expand naturally. They move toward states with more microstates and higher entropy. Temperature also affects microstates. When the temperature rises, particles gain more energy and can occupy a wider range of energy states. This increases the number of microstates available. Similarly, when a solid melts into a liquid or a liquid vaporizes into a gas, the particles become less ordered. This change increases the microstates and boosts the entropy. In simple terms, microstates are like the different ways you can shuffle a deck of cards. The more ways you can shuffle it, the more unpredictable and disordered the deck is. The same idea applies to particles in a system. The more arrangements they have, the higher the entropy. This statistical view helps us understand why natural processes tend to move toward states with more microstates, because those states are more probable. So, microstates are the microscopic details that make up the big picture of entropy. When the number of microstates increases, the system becomes more disordered, and entropy rises. This connection is fundamental to understanding how and why systems change over time in the world of thermodynamics.